Your dog is alive today because its ancestors were losers. Not slow losers, not weak ones. The ancestors of every wolf, every fox, every golden retriever sitting on your couch right now, they survived because they were smaller, lighter, and less powerful than the dog that actually dominated this planet for 7 million years. And that dominant dog, gone. Every single member of its entire family line, wiped out completely. Not by an asteroid, not by a volcano, not by some catastrophic flood that ended everything at once. It was beaten by cats. Let that land for a second. The largest, most powerful dog that ever existed on Earth, an animal with the skull of a lion, jaws that could crack open bone like dry pasta, and a body heavier than a brown bear, was outcompeted and driven to extinction by cats. And the small, average-looking dogs that ran away from fights survived to inherit the entire planet. This is the story of Epicyon, and once you understand what this animal actually was, you're going to look at your dog completely differently. 40 million years ago, North America was unrecognizable. No cities, no highways, no humans, just massive open landscapes, ancient forests, and a world full of animals that have no living equivalent today. And in that world, the very first dogs were taking shape. These early dogs weren't impressive. They were rough, flat-footed, slow-moving animals eating whatever they could find. But over millions of years, they began splitting into different branches. One branch stayed small and flexible, another faded entirely, and the third branch made a decision, biologically speaking, that led to something extraordinary. That third branch was called the Borophagini. The name translates directly to bone-crushing dogs, and for 30 million years, they were among the most dominant predators North America had ever produced. More than 60 individual species, every single one of them found only in North America. Nowhere else on Earth, no fossils on any other continent. They owned this land completely. At the peak of their power, they dominated ecosystems from the eastern forests all the way to the open western plains. They weren't one type of animal. They ranged from fox-sized generalists to bear-sized apex predators. And the largest one they ever produced was Epicyon haydeni, the biggest of 3 known species, measured 2.4 meters long, stood 90 centimeters at the shoulder, weighed between 100 and 170 kilograms depending on the individual. The largest specimen ever found, estimated from a single enormous arm bone, was comparable in size to a male African lion. No dog before it reached that size. No dog since has come anywhere close. And yet, this animal, at the absolute peak of its power, ruling a continent for millions of years, it lost. The reason why is going to change how you think about what it actually means to be strong. Here's something nobody tells you about evolution. The scariest animals in history didn't start scary. They started as something completely forgettable. The earliest borophagines appeared around 34 million years ago during a geological period called the Oligocene, and at that point, they were nothing to worry about. Small, slow, flat-footed, they walked on the full sole of their foot, the same plantigrade posture you see in bears today, which is actually a slower, less efficient way to move than walking on your toes. They ate plants, insects, small animals, whatever was available. They were opportunists in a world already dominated by an older and more established dog family called the Hesperocyaninae. Nobody would have bet on these animals becoming anything remarkable. But they kept changing. Slowly, across millions of years, the borophagines started growing. Their diet shifted toward meat, their skulls got denser, their jaw muscles expanded, their teeth became more robust with every generation. And as they improved, something interesting started happening to the older Hesperocyaninae dogs. They began disappearing. This wasn't bad luck. The borophagines were filling the same ecological roles the older dogs occupied, but doing it better at every level, more efficiently, at larger body sizes, with stronger hunting tools. By around 15 million years ago, every single species of Hesperocyaninae was extinct. An entire family of dogs gone. Not from any external disaster, but from direct competition with a better adapted relative.
The Borophagians had taken over completely. And from that dominant position, from 30 million years of accumulated evolutionary refinement, Epicyon emerged. There were 3 recognized Epicyon species. Epicyon davies and Epicyon oreodontoides were both wolf-sized, genuinely impressive animals by modern standards, comparable to a large gray wolf. They would have been dangerous predators in any environment on Earth today. But Epicyon hydeni was categorically different. When paleontologists first began recovering hydeni fossils across sites in the American West and Midwest, the size estimates were difficult to accept. A humerus, the upper arm bone, recovered from one site was so large that the weight estimate derived from it reached 170 kilograms. For context, the average male African lion weighs around 190 kilograms. The largest gray wolves alive today reach around 80 kilograms on the very high end. Epicyon hydeni wasn't just a big dog. It was in a completely different size class from anything the canid family had produced before or has produced since. What makes the fossil record even more fascinating is that hydeni and the slightly smaller davies lived together across overlapping territories for millions of years. At every fossil site where both species appear, the size difference between them holds at a consistent 16 to 23%. Both species also grew larger over time, in parallel, together, but always stayed proportionally separated from each other. Some researchers wondered if they were simply males and females of a single species. That idea was rejected firmly. No living canid shows that level of size difference between sexes. Detailed analysis of tooth geometry and skull proportions confirmed what the numbers suggested: 2 genuinely separate species occupying slightly different ecological roles in the same environment, evolving in coordination across millions of years. From a forgettable fox-sized omnivore to a bear-sized apex predator. 30 million years of relentless refinement, and it still wasn't enough.
If you found Epicyon's skull in the ground without knowing what it was, you would not guess it came from a dog. You would guess lion. The skull was short, wide, domed across the top in a way that looks completely wrong for any canid. Every modern dog, from Chihuahuas to wolves, has a relatively long, narrow snout. That shape is functional. It provides space for scent receptors, allows for efficient gripping of prey, and works well for the specific type of hunting dogs specialize in. Epicyon's skull abandoned that design entirely, and the reason it did comes down to pure mechanics. A shorter snout positions the canine teeth physically closer to the jaw joint, the fulcrum point where all the bite force originates. Basic physics tells you what happens next. The closer your force is applied to the fulcrum, the more mechanical advantage you generate. It's the same principle that makes a short-handled nutcracker more powerful than a long-handled one. In Epicyon, this design produced bite strength that exceeded every canine species alive on Earth today by a significant margin. But the canines were only the opening act. Behind them sat a set of teeth called carnassals, the scissor-like shearing teeth that almost all carnivores use to process meat. In wolves, coyotes, and virtually every modern dog, carnassals are blade-shaped. They slice, they cut through muscle and connective tissue with efficiency. In Epicyon, they were something else entirely. Broader, dramatically more robust, built less like scissors and more like industrial crushing platforms. When the upper and lower carnassals came together under full jaw pressure, they generated enough force to crack open large leg bones, fix skulls, and dense skeletal material that every other predator in the ecosystem simply walked away from. Further back in the jaw, Epicyon's molars were wide and flat, almost grindstone-like, suggesting it wasn't exclusively eating meat. It likely consumed plant material or insects occasionally, but researchers classify it firmly as a hypercarnivore, meaning more than 70% of its total diet was animal tissue. The wear patterns on Epicyon's fossilized teeth are one of the most telling pieces of evidence. They match almost exactly the wear patterns found on the teeth of modern spotted hyenas, the most accomplished bone-crushing specialists currently alive.
And then there's the physical confirmation. Fossilized feces attributed to Epicyon have been recovered and analyzed, and they contain actual bone fragments, not just signs of bone contact, bone inside the digestive waste. This animal wasn't only crushing bone, it was fully digesting it. That detail matters more than it might seem. Bone marrow is one of the most calorie-dense substances found in any animal carcass. Fat content, proteins, nutrients that are completely inaccessible to any predator that can't break through the bone to reach it. While every other large carnivore in Miocene North America abandoned a carcass when the accessible meat was gone, Epicyon could crack the skeleton open and extract everything the others missed. It had a private nutritional resource that no competitor could touch. Below the neck, the body was built differently from the skull. Epicyon walked on its toes, the efficient posture that modern wolves use, which lengthened the stride and improved running mechanics. Small collarbones and a flexible spine added further mobility. These features suggest it operated primarily in open environments rather than thick forest. But at over 100 kilograms, the long-distance endurance running that defines wolfpack hunts was simply not available to it. Its limb proportions show it was less built for sustained pursuit than modern wolves. It was fast in short, explosive bursts. It closed distance quickly. And then, the skull did the work. A biological weapon that evolution spent 30 million years building.
Miocene North America looked nothing like the continent you know. 50 million years of evolution had produced a landscape full of animals that have no living equivalent anywhere on Earth today, and Epicyon moved through that world at the absolute top of the food chain. Epicamelus, a camel species that stood 3 full meters tall on impossibly long, stilted legs, moved across the open grasslands in herds. Telocirrus, a rhinoceros built with the wide, low body of a hippopotamus, grazed along the ancient river systems that cut across the continent. Prehistoric horses moved in groups across increasingly grass-dominated terrain. Giant pronghorns, massive ground sloths, enormous herbivores spread across the landscape in densities that would be shocking to see today. Epicyon hunted all of it. Based on jaw mechanics and body size, Epicyon was physically capable of targeting prey significantly larger than itself. A 170-kilogram predator with bone-crushing bite force doesn't have many animals on the menu that qualify as off-limits. But exactly how it hunted is one of the most genuinely unresolved debates in canid paleontology, and the answer shifts dramatically depending on which bones the researchers are studying. One research team analyzed Epicyon's elbow joint morphology and concluded it had developed an ambush-style attack, more consistent with how a big cat operates than how a pursuit predator functions. A completely separate study examined the bony labyrinth, the structure deep inside the inner ear that controls balance and spatial processing, and found evidence of a pounce predator, something that launched itself at prey from close range rather than running it down over distance. A third analysis of overall forelimb proportions pointed towards something in between, a combination of pursuit and pouncing that has no clean modern equivalent. The uncomfortable truth is that Epicyon doesn't fit any living animal's behavioral template. It occupied a predatory category that simply no longer exists. Whether it hunted alone or in coordinated groups is equally unresolved. The argument for pack behavior rests on a practical problem. Canid forelimbs are not built for grappling and pinning large prey the way big cat forelimbs are. Without that grappling ability, bringing down a 3-meter camel alone would be extraordinarily dangerous. Numbers and coordination would solve that problem. And Epicyon haydeni fossils are remarkably widespread and relatively common across late Miocene fossil sites, which suggests this was not a rare, solitary creature maintaining exclusive territories. The argument against pack behavior points at the skull, the limb structure, and the ambush-adapted elbow morphology, all of which look far more like a solitary predator than a cooperative one. Using modern wolves as the behavioral model for an animal this different from wolves may be fundamentally the wrong comparison. The most accurate description researchers have landed on is genuinely strange.
Epicyon may have been a dog that lived like a cat. For 7 million years, it dominated. And then, from a direction nobody saw coming, the real cats arrived.
Here's the thing about the cats. They didn't arrive all at once. The family Felidae evolved in Eurasia around 33 million years ago, but for a long time, a very long time, North America had no cat-like predators at all. Paleontologists actually have a name for this absence. They call it the cat gap, a window of more than 7 million years during which the borophagonines had zero competition for the ecological roles that felids typically fill on other continents. So the bone-crushing dogs filled those roles themselves. They developed ambush hunting. They evolved the ability to rotate their palms upward, a grappling adaptation you normally see only in cats. They became the solitary, explosive, short-range killers of an entire continent. In the complete absence of cats, the borophagonines became as close to cats as a dog can physically get. And that decision, that evolutionary direction, is what ultimately destroyed them. Around 20 million years ago, the first felids crossed from Eurasia into North America via the ancient land bridge connecting modern Russia and Alaska. The early arrivals were small, unspecialized. They struggled to establish themselves in an ecosystem already dominated by experienced, well-adapted borophagonines. For millions of years, the cats barely made a dent, but they kept improving, and once they found their footing, the shift was rapid and brutal. These cats had retractable claws that stayed razor sharp because they never made contact with the ground during walking. They had forelimbs built specifically for grappling, for grabbing, controlling, and pulling down prey in ways that dog forelimbs physically cannot replicate. And as felid diversity expanded, some species developed elongated canine teeth capable of puncturing the throats of prey animals almost regardless of size. A study analyzing over 2,000 North American carnivore fossils reached a conclusion that removed any ambiguity about what happened next. The decline of the borophagonines was not passive replacement, not a slow, natural fading while cats organically filled the empty space. It was active displacement, direct competition. The cats challenged the bone-crushing dogs for niche after niche and won each one. The borophagonines had no effective counter. But here is the part of this story that most people miss completely. The cats didn't destroy all dogs, only the ones that were trying to be cats. The canines, the other surviving branch of the dog family, had taken a completely different evolutionary path. Smaller bodies, lighter frames, stamina over power. They had specialized in long-distance pursuit hunting, running prey across open ground until it collapsed from exhaustion. That niche held no appeal for cats. Felids are ambush predators by biology. They lack the cardiovascular and muscular architecture for sustained endurance running. The canines kept that lane entirely to themselves, and the cats never tried to take it. By 8 million years ago, canines had crossed into Eurasia and begun their global expansion. Today, they represent 37 wild species across every continent except Antarctica. Epicyon haydeni disappeared from the fossil record around 5 to 6 million years ago. The last borophagonine, a genus called Borophagus, held on until approximately 2 million years ago, before finally going extinct. 30 million years of evolution, gone. What survived was the dog that didn't try to be the strongest thing in the room, the dog that ran when others stood and fought, the dog that cooperated when others went alone, the dog that eventually ran alongside humans and became the most widespread large carnivore in human history. Strength didn't determine which dogs inherited the earth. Adaptability did, and the most terrifying dog that ever lived never learned that lesson.